Assalamualaikum and a very good day. Welcome to my presentation for the first UMS Colloquium on Fundamental Research and Application UMS CoFA 2020. My name is Dayangdini Amani binti Awamat Daud and I'm going to present a paper entitled Design and Development of a Sustainable Aquaponic System. The other authors in this paper is Dr. Pham Nhan Nhan, Dr. Muhammad Azlan bin Ismail and Dr. Arolan Kiring. Now let's get started with this presentation. Now what is aquaponics? Aquaponics is the combination of aquaculture and hydroponics. It is usually made in large scales to harvest plants and fish in food industries. It is also one of the solutions in unraveling the unsustainable use of water in the world. Now let us get into the aquaponics system cycle. So the fish inside the fish tank will produce waste. The waste will then be converted by the bacteria to become nutrients. The plants will absorb all the nutrients and then will provide clean water and oxygen back to the fish, and the cycle goes on and on. Aquaponics are well recognized in urban cities and are made in small scales but usually used for hobbyists. Aquaponics in small scales were not all practically made to be easily maintained and sustainable. So, the major issues in an aquaponic system is the inconsistency of water quality that could affect the fish and plant health, and next is the high energy consumption to enable high flow rate of water flow for water and nutrients throughout the system. And lastly is the energy required by humans to monitor and maintain the water condition other than feeding the fishes. Here is the comparison of the water condition in a fish tank without using an aquaponic system and the water condition in a fish tank with using an aquaponic system. As we all know, the water condition in a fish tank are not always consistent. So, from these figures, it shows that the fish tank with using an aquaponic system has much clearer water in the tank compared to the fish tank without using the aquaponic system. This is due to the accumulation of fish waste that causes high energy consumption of the pump. Here are some factors affecting aquaponic system. The first one is the shape of the tank. Non-circular tanks has a complex nature of flow due to its corners, which will cause the accumulation of fish waste. Next is the implementation of a bell siphon. It is used to avoid overflow of water. Lastly, it is recommended to use oversized pipes to reduce the effects of biofouling. This is because some remains will form inside the pipe and will restrain the water flow. Now, the main objective of this paper is to design and develop a sustainable aquaponic system, which can be divided into two specific objectives. The first one is to design and develop a sustainable aquaponic system with an energy-conserved self-cleaning drain pipe designed to enable smooth flow of water and nutrition throughout the system. The second one is to build a smart monitoring system to observe the temperature and pH value of the water in the system with the use of Internet of Things technology. Here is the aquaponics design. Now, the design was made using a SolidWorks software. Other than designing in this software, the software is also used for flow simulations. The major components in the aquaponics design is, first of all, the fish tank. Second is the grow bed for the plants, a bell siphon, a self-cleaning drain, a submersible pump, and a tube from the submersible pump. And this is the dimension and size for the fish tank. The area used is 3 square feet, and the dimension for the fish tank is 16 inch by 12 inch by 10.5 inch, and the dimension for the grow bed is 16 inch by 12 inch and 5 inch. This is the simulation analysis used to determine the suitable position for the self-cleaning drain system. As we all know, waste settlement occurs at the corners of the tank. And based on the figures, it shows that the drain systems are best placed at the corners where the velocity are much more higher compared to the middle drain system. The high velocity will help to move the accumulated waste at the corners to move throughout the drain pipe that is placed at the corner. This is another simulation analysis based on the pressure flow trajectories for the corner drain and also the middle drain. The pressure for the rectangular tanks are higher at the corners compared to the circular tanks since the pressure in circular tanks are equal. Middle drain pressure makes it harder for the waste to move out. Now let's get into the smart monitoring system. So the components used in this system is the DS18B20 temperature probe, the E201C pH sensor, and the Arduino Wemos D1R1 board, which is an ESP8266 based. The ESP8266 module are Wi-Fi based board that allows the monitoring to be done via Android application that is used in this system, which is called Blink. So how does it work? The Arduino Wemos D1R1 will be connected to a power supply, and it will activate the temperature sensor, the pH sensor module, the ESP8266 module. The pH sensor module will be connected to the pH sensor, and the ESP8266 module will be connected to the Blink application in the Android device. Now this is the Blink display showing the pH and temperature results of the water in the fish tank. It gives a temperature of 26.25 degrees Celsius and a pH value of 8.5. Now this is the results of using the sensors in two different types of water to obtain the value of the pH and also the temperature. The optimum pH value for water is between 7 to 8. This shows that the sensors are working fine. This is the location for the pH sensor and the temperature probe. And this is how the smart monitoring system works in the system. For fabrication of this prototype, the material used is PVC. Next is the self-cleaning drain pipe flow, which is implemented to reduce the accumulation of fish waste and avoid overflow in the fish tank. The self-cleaning drain pipe is made with a combination of a simple drain system with an addition of a bell siphon concept. It is simple and it does not require a lot of energy, and it does not require much space too. Now how does the self-cleaning drain pipe work? The fish waste will move towards the drain due to the movement of the fish and also the movement of the water from the atmospheric pressure that is pushing the water out from the drain. The bell siphon concept is then used in the self-cleaning drain pipe by avoiding an overflow of the water in the fish tank and also to maintain the level of the water in the fish tank. Now here is the data collected to get the performance of the fish and plant growth with the implementation of the self-cleaning drain and the smart monitoring system. The two figures shows the fish length and plant growth comparison against time for 2 weeks. The blue legend indicates the plants and fish growth without using the self-cleaning drain, and the orange legend indicates the plant and fish growth with using the self-cleaning drain. From the graphs, we can say that the uses of the self-cleaning drain changes the growth trend drastically. Now pH plays an important role in the growth for both aspects. This graph shows the pH value comparison for using and not using the self-cleaning drain. We can see that the pH value increases drastically without using the self-cleaning drain throughout the 2 weeks. This will slow down the growth rate for the fish and plants. Now this table shows the temperature value for different hours. The temperature changes every hour but does not change rapidly, especially here in Malaysia. Most fishes can withstand temperature changes for hours except for rapid changes. Now this is the comparison for the water condition without using the self-cleaning drain and with using the self-cleaning drain. As you can see that the water condition with using the self-cleaning drain are much more clearer than the water condition without using the self-cleaning drain. Now this is the growth rate results for the fish and plants. In figure 20A shows the fish length in the beginning of the project, which is 2.9 inches, and in figure 20B shows the fish length at the 7th week of the project, which is 5 inches. Figure 21A shows the plant growth in the beginning of the project, and figure 21B shows the plant's growth at the 7th week of the project. In conclusion, the SolidWorks simulation achieved in determining the settlement location for the fish waste. Next, the self-cleaning drain gets to reduce the waste accumulation and settlement and avoided overflow of water. Other than that, the smart monitoring system gets to determine the optimum pH range for the growth performance, which is between 6.5 to 8. And lastly, the implementation of the self-cleaning drain helps to increase the growth performance for the fish and plants. These are some recommendations for future works. So the first thing is the design should consider to avoid biofouling inside the pipes and how to maintain and clean them. Second is adding an alert system to alert the users on the condition of the water either via mobile phones or from the prototype itself. And third is improving the smart system by adding an automated feeder that can be controlled via the mobile phone. And that is all from me. Thank you for your attention.